Good morning, sir. My name is Lorez, and my student ID number is 2102294. And this is my presentation for why is it important to use a system analysis and design methodologies when building a system, and why not just build the system in whatever way seems to be quick and easy, and what value provided by using an engineering approach. System analysis is important because it provides an avenue for solutions in the system through the various tasks it involved in doing this analysis. Through these various tasks, the overall quality of a system can be easily modified or improved, and occurrences of errors can ultimately reduce. Let's go and over them one at a time now. It is important to use system analysis and design methodologies when building a system because it ensures the quality of the system being built. It is also test and you are following a process that very structural. If you build a system in whatever way seems to be quick and easy, it can result in a poor development system. Yes, it can be easier and cheaper, but in the long run, it can require extra work, and more money to maintain it. It is important because improperly coded algorithms can crash the system or require geometric scaling resources. Performing system analysis and using best practice methodologies helps prevent common bad coding techniques. You should not build the system in whatever way seems to be quick and easy because that just means cheap and unreliable. In tradition, it is not easy to build a system in whatever way seems to be quick and easy because nowadays, system development focuses on system integration, which allows hardware and software from different vendors to work together in application. And next question is, value provided by using an engineering approach. System planning and selection, priorities for system and projects. Number 2 is detailed work per plan for selected project. And system analysis, description of current system. Number 2, general recommendation on how to fix, enhance, and replace current system. System design, detailed specification of all system elements. Thank you again, sir. My name is Lorez, and this is my representation for number 1.
Good day, sir. I am John Kerwin E. Caballes, and my student number is 2101068. I'm going to answer the number 2 question. Describe your university or college as a system. What is the input, the output, the boundary, the components, and their interrelationship, the constraints, the purpose, the interface, the environment. Draw a diagram of this system. The college as a whole is made up of many parts known as departments. Each department has unique identity that differs from the others, but they are related because they are part of the same institution and cooperative to run efficiently. Graduate students were the outputs, with profession and potential students is being the inputs. The bounds are set by the school standards, which include requirements for appropriate attire and identification as a pamantasan ng kabuya student from other school. The Department of the College, the Department of Faculty and Staff, the Business Office, the College Dean, and the Executive Vice President Office made up the components. Every department had a duty to the students they serve, but they also had a duty to obey others from the higher authorities, such as College President or Dean, which is why the departments were interconnected. The number of academic staff members was a limitation. The guidance office and the registrar can act as a point of contact for the school. The legislative, prospective students, local laws, and news could be all considered as environmental factors. That's all, sir. Thank you.
In the Philippine Islands, the Commission on Higher Education bestows the designation university system on a private or public higher education institution that meets specified criteria. According to the Commission's A university system is an academic organization made up of different but interconnected entities, at least one of which has university-level status. The design of system-wide policies and program is the responsibilities of a single governing body. A university system has its own system and administration, which is led by a CEO. Its primary responsibility is to coordinate and integrate system-wide operation and activities. Each component unit has its own chief executive officer, to whom the governing board gives wide authority for the constituent unit formation and functioning.
Hello everyone, I am Daryll Fajardo and my student number is 1902625 and I will be discussing the problem number 3. So here's the problem number 3. Choose a business transaction you undertake regularly, such as using an ATM machine, buying groceries at the supermarket, or buying a ticket for a university basketball game. For this transaction, define the data, draw the data flow diagram, and describe the processing logic. So, the information for an ATM transaction includes the customer's name, account number, personal identification number, account balance, transaction type, and the transaction amount. The customer enters the ATM card to the machine, after which the customer enters his PIN number. The machine in turn validates the number if it corresponds with the data of the card. When the PIN number is validated, the machine will ask the customer what kind of transaction he will take. As the diagram shows, a withdrawal, the customer will then enter the amount he will withdraw. The ATM will check if the account has enough cash for the amount. After that, the machine will dispense cash. The process will end with customer getting the cash and then the card from the machine. Do not worry whether or not the customer knows the technique. At this point, it is more important that the student can analyze the transaction, break it down into its component parts and pieces of data, and understand the process. That's all. Thank you.
I am Karl Ibayan and my student number is 1904247, and I'll be reporting the how might prototyping be used as part of the SDLC. The same screen or feature can be built in a variety of ways when developing software. However, only a few paths will lead to user-friendly functionality. This is where software prototypes came into play. Continue reading to find out what they are and how they are used to develop successful software products. In software development, a prototype is a simulation of how a real product will work and feel. It is used to provide design feedback as well as user testing. A prototype can also serve as simulation for an entire mobile app or just one digital interaction, depending on your needs. Software development is a similar process. Prototypes are frequently used to collect early feedback and make changes as needed, rather than allowing a development team to fully code the application. Most prototypes are used to gather useful feedback before writing a substantial amount of code. Prototypes can be used early in the life cycle to deliver proof of concept deliveries that can be used to justify additional investment in the project. Prototypes are also helpful when translating preliminary user experience design concept into actual code. And these are the different types of software prototyping. Number 1 is handmade drawings or paper wireframes. The goal of a paper prototype isn't to come up with the final polished design, so don't worry about artistry instead. It can be an important step in bringing a vague idea to life. The hand drawing step forces you to move to the concrete. Even simple paper drawing can clarify your ideas to yourself and others. It also helps you make a key decision about what to include or not include in an initial project scope. Number 2 is wireframes. A step up from paper sketches are wireframes or low fidelity design, which are 2D skeletal outlines of a software application. Wireframes are also a visual representation of the software and focus on functionality, user flow, and how screen will relate to each other. They only include key elements and they are fast to easy to make. They're great communication tools for eliciting feedback and ideas from stakeholders and users during the design process. The rough feel encourage others to make honest comments because they know features are still being clarified and changes are expected. And the last one is clickable prototypes. Clickable prototypes lets user interact with it on a computer or a mobile device. You'll be able to click on buttons and move fluidly between one screen to the next like real software. Wireframes can turn into clickable prototypes, which are an interactive set of linked visual screen that can mimic a working app. You'll have a clear sense of what the final software will look and feel like, but it's still easy to make changes as needed at this stage.
My name is Kenneth Aquino, and my student number is 2100991. And I will describe the difference between in the role of a system analyst and the software development lifecycle, SDLC, and versus prototyping. The SDLC or software development lifecycle has a systematic procedure that enables business to quickly generate high-quality, tested software, which is the primary difference between the SDLC and prototyping. The SDLC has several different models including waterfall, spiral, and agile. Each contains at least 6 fundamental steps. This follow best practices, and each phase ensures that the software runs successfully, easily, and effectively. Prototyping. Prototyping is defined as designing and building a scaled down but functional version of desired system. Dixit says that a prototype can be built with any computer, language, or development tool. In contrast, SDLC or software development lifecycle is a system development approach which follows step-by-step procedures. Prototyping is the process of developing a system model in order to help system designers create user-friendly, intuitive system. Prototypes are employed in the development of information system.